Very good afternoon to you all. Our university, the Shiv Nadar Institute of Eminence, is convening a very special gender initiative today. We have gathered today to explore the problem of gender equity in higher education. I would request, I think Professor Ananya is not there, so I will directly go to Professor Rohini. I'll request Professor Rohini Godbole to begin the program. She is the coordinator of this panel discussion today. She is a renowned physicist and an ardent advocate of gender equity. Her widely read work, Leeravati's Daughter, is a collection of nearly 100 biographical essays on women scientists of India. She is a Padma Shri recipient, an honorary professor for the Center of High Energy Physics, Indian Institute of Science, and a distinguished visiting faculty of the Shiv Nadar Institute of Eminence. So, yeah, ma'am.
I would welcome everybody on behalf of Professor Ananya Mukherjee and myself, because as was said by Srijitha, this is actually the inaugural event of a gender working group that the Shiv Nadar Institute of Eminence wants to start. And I think I'm just saying this on behalf of the Vice Chancellor, Professor Mukherjee. So welcome you all for this first event. And this specific event is the prelude to the panel discussion, which is a prelude to the International Conference on Women in Physics, which is going to happen in July 2023 in India, a completely online conference. So I will request now Srijitha to first conduct the meeting by asking Professor Vandana to begin the proceedings.
So, because Ananya ma'am is not there, I'll just give a brief introduction a little bit more. This is a preliminary event and it's an initiative of the International Conference of the Women in Physics, ICWIP, under the aegis of the Gender in Physics Working Group. So, Professor Vandana Nanal is a professor in the Nuclear Physics Laboratory at the Tata Institute of Fundamental Research, and she is the co-chair of the Indian Council of the Women of Physics 2023. So please, Vandana ma'am.
Thank you. And let me start by sharing my screen. 1 second. I have too many. Okay, I hope you all can see my screen. Yeah, so I'm speaking in the capacity of the chair of IPA Gender in Physics Working Group and co-chair of IPWG organizing local organizing committee, and Professor Shubhavati Goswami, who is also a co-chair with me. She is in the audience and she is the past chair of the gender. I'll talk about gender group in a minute. So Indian Physics Association was founded in 1970, basically to provide a platform for facilitating interactions among the physics community in India. And information about this can be found on the web page, and these are the contact addresses, as well as it says a presence on social media. Since we are talking at SNU and some of the people may not know about it, I'll give a one-slide introduction to IPA. It has about 47 chapters and close to 4,500 members. What does IPA do? The chapters are spread over the country, as you can see here. And what the IPA mainly does is it arranges several special lectures, liaises with national bodies like academies, and the international linkages with the partner physics societies. In the last few years, utilizing the online platform, IPA has held several hybrid events and online events, particularly with APS. IPA has a strong linkage with IOP UK, and there is a biennial lecture series which runs. In addition to this, IPA publishes the physics news. It's a quarterly bulletin. It's available on its website completely in the online format. And some of these links I will also put in the chat box. All the information is available on the IPA webpage. It's very easy to join an IPA. You can just go to the web page, go to the new registration, make the request. Your application needs to be endorsed by one of the IPA members, and IPA membership information also for the information in your region and chapter is available on the web page. The Gender in Physics Working Group of IPA was established in 2017. The idea was to provide a platform to address various issues related to gender parity in physics profession. As most of you are aware of, the gender inequity in STEM subjects, that is all science-related subjects, is a matter of concern, and the problem is particularly acute for physics and maths, and India is no exception. The current group members are here. Again, we have a web page and more information will be available on the web page. As you can see, the members come from different parts of India and different subjects. And there are other bodies like ASI which have gender working groups. So IPA, GIPWG interfaces with them, and we have the chairs of those groups are co-opted so we can work in a more cohesive manner and share all the ideas, which is the goal. The EQUIP 2023 is the 8th International Conference on Women in Physics. This is the series started by the Working Group 5, which was set up by IUPAP for addressing the issue of the gender paucity in physics. And this conference happens every 3 years. The last one also, because of the COVID, was online in Australia. And this one we hope is the last of the online type, and next one will be in person. So this conference will happen between 10th and 14th July in online mode. And the conference is jointly organized by GIPWG, TIFR with Homi Bhabha Center for Science Education, one of the centers of TIFR as the nodal agency. More information about the conference is available on this site. And I must say that various plenary sessions, the conference will consist of plenary talks, posters, panel discussions, interactive workshops, and several satellite events are organized around it. And I'll tell about it in a minute. But most of the plenary sessions of the conference will be available to a wider public after the conference on the YouTube. So we are trying to make use of the online platform to the full extent. As of now, we have more than 400 registrants from 70 different countries. The conference has a slightly different way of organization. Each country is asked to send a team of about 5 members, and they present the country posters telling what is the state of women in physics in their country, what are the developments in the last few years. And in addition, the women participants also present technical posters. There are poster session also on women in physics. The conference right now has about 80 students registered from different countries all over the world, and also have each team is supposed to have 1 male member. So we have a fairly good gender fraction distribution even in this conference. What you see on this slide are the special physics news issues which were brought out with the efforts from GIPWG current and the former members. A special issue was brought on in 2017 featuring the research done by women in India by all women authorship. In 2021, we brought out a special issue on Bibha Chaudhary, the first woman experimental particle physicist in India. And current issue also, which will be released early next month, is also showcasing the work done by young women researchers in India. These are on the right, you see, are some of the satellite events which we have started. One of the important events which is running for last 6 months is Pavinari, Padartha Vigyan Ki Nariya, lecture series on women physicists. We have had 6 lectures and we hope this will continue. This series is available on the GIPWG YouTube channel. The GIPWG also has started a series of interactive workshops called PAUSE, Program for Aspiring Women Scientists. These essentially include career guidance and combating biases with contextual examples. Today's event is one of the satellite events prelude to EQUIP, and similarly on 8th of July, just on the eve of the conference, we will have another event at GITHAM University. There will be a interactive workshop on digital teaching physics effectively online and women in STEM, followed by a public lecture. We had several other events. I'm not going into details of all of it. So now I'll just stop here with this slide, that if you want to get in touch with GIPWG or know more about us, please visit our webpage. We do have a presence in YouTube and other social media. And this is our email address. We have also initiated a Google survey to create a database of women physics faculty. So please pass this word to your friends. Please visit our webpage, and there will be just a Google form to fill. And I'll also share all these links here. I look forward to this. Today's topic is something, again, very close to the heart of many of us. And I really look forward to a brainstorming session. Thank you.
So, can you stop sharing the screen?
Yeah, I did that.
So, all right. So, I will start now with giving a short introduction to the panel discussion that we are having today. Some of it has already been made, and to the panelists. So let me begin by sharing my screen. So let's see if I can, yeah. Okay. Can you people see my screen?
Yes.
Yeah. So as already mentioned, this is a panel discussion, and the subject is our MCQ tests gendered. That's the title. And as was already mentioned by two people, this panel discussion is taking place as a prelude to the International Conference on Women in Physics. And the idea is actually to be able to report to the conference what might be the recommendations and the conclusions that we will arrive at during the discussion today. So let's see what we can manage. So the idea is today to discuss three things. One is whether is there a gender dependence of the fraction that clears the various entrance tests for higher education in STEM in India? Does this really depend on the type of the entrance test? And do the MCQ tests add to this gender divide? If yes, then what are the possible reasons? And should one or can one correct for it? These are kind of three questions. Now, the Indian scene on women students in physics or women participants in physics in general, and generally STEM, looks something like this, which means that at the student level, at the undergraduate and the master level, we have actually a sufficiently large fraction of girls students. And it is this normally, in my usual discussions on women in science, I begin discussing this fall. But I think today what we are really focusing on and looking in more detail with a magnifying glass is this 40% and seeing what is the distribution of this 40%. So if you go to the data, look at the data for the last 10 years on the web page of All India Survey of Higher Education, the gender equity index in numbers is almost 1.0, and which is not unexpected given the fact that these numbers here are something like 40-45% of the girls. But the interpreting numbers is always very tricky, and the data themselves actually indicate many other interesting features, that the share of female students is not uniform 40% across. It is lowest in institutes of national importance, one of them being the Shiv Nadar Institute of Importance, such as it's today, where this panel discussion is happening. And then the next one comes deemed university of government, and then state private universities. And there you see that the percentage of the girls goes on increasing as you go towards from the institutions of national importance to the universities and then to the state private universities. So, and if you go to the Indian Institute of Technology, then this fraction even goes down to 10 to 12%. So this is the, at least in the undergraduate student population, this is the gender fraction. Now, if one looks at the merit list of the university examinations, girls dominate, whereas the fraction of girls clearing the joint entrance examination for engineering or joint entrance test screening test, JEST, PhD in natural sciences. And the now scrapped Kishore Vaigyanik Protsahan Yojana, KVPY, all over the place, the fraction of girls clearing these exams is rather small. And one natural question that begs is that, is this because these tests are multiple choice question? Is there dependence on the type of test that happens? And here I would like to share with you actually an experience I had maybe 20 years ago, when I was trying to give a talk advocating that there should be more women in science. And then one of the directors of the institute where I was giving this talk actually very flatly told me that yes, girls are good, they can do good, well in university exams, but when it comes to tests like the joint entrance exam or KVPY or some such counterpart, then they're just not good enough. On the other hand, the UPSC examinations also have MCQ as one part. And at least these days, we hear of large number of women excelling there. Of course, I have no idea of the percentages there. So, because of course, it's one thing to talk about average trends and another to talk about distributions at the top. Now, just let's give an idea of the kind of numbers we have dealing with. That just this last week, the JEE results were out. And I just saw this on the newspaper, that 189,744 students registered, 180,372 appeared, and 43,773 cleared. So these large numbers really mean that MCQs are perhaps unavoidable, and the fraction of girls normally who clear this JEE is much smaller than the boys, the fraction of girls who attempt the one who clears. There was a comparative study by IIT Alumni and MIT Alumni from about 10 years ago, and the title was, Do the Test Engineer a Gender Divide? And I will just write down the headline. The selection rates for males in IIT was 6.4%, and for women it was 1.9%. Whereas for MIT, these numbers were 7.2% and 15.5% respectively. And the big difference was that IITs chose based only on the score on the standardized tests, whereas MIT used other criteria for selection. And therefore, at MIT, all the selected candidates were not necessarily from the top of the merit list of the standardized tests. This is just one point that they had pointed out. This is just one aspect of this very complicated and multifaceted subject. And today's discussion, I hope, is one of the early steps on a road of critical study of possible contribution of the MCQ tests to the gender divide, if they contribute any. And in fact, I think it's not just gender aspect that needs to be considered. Perhaps we need to consider in a future this thing about where the language in which the tests are conducted and the mother tongue of the students and so on and so forth. I mean, inclusivity always comes in many, many angles. But right now we are going to be discussing gender. We have 5 experts, and I'm not going to read their bios because the bios are given on the poster, but I will introduce them in 2 lines. Professor Roopmanjari Ghosh is a physicist and has been the VC of the Shiv Nadar Institute of Excellence. Now, she is the past VC, and she has extensive experience in physics research as well as education. Professor Debashish Ghoshal is a theoretical physicist, has been at the Harishchandra Research Institute and it's current now at the Jawaharlal Nehru University. He has extensive experience in research, education, teaching and research guidance. He is involved in a number of entrance tests at HRI, at JNU and so on. Professor Nisim Kanekar is an astrophysicist. He's working at the National Center for Radio Astronomy, NCRA. Again, he also has a large number of years in research and has been closely involved in various entrance tests of NCRA, TIFR, and actually has also analyzed data for the same. Professor Kate Wilson, I would particularly welcome her because it's now, and thank her because it's the end of the day for her. She is joining us from University of New South Wales in Canberra. She is a professor of physics, but she has done extensive research in pedagogy, and MCQ are her special interest. Professor Nandini Chatterjee Singh, who is a physics PhD, she did research on nonlinear phenomena and now has moved to brain research and cognition, and she's an expert and can talk about psychometric aspects of education. So you can see that we are lucky to have here experts from different aspects, different areas, and who have looked at MCQs or who have been involved in MCQs in different capacities. And I'm looking forward to a very extensive and important brainstorming, as Vandana said. I will stop sharing this and come back to this slide during the discussion when I want to ask a question to the panelists themselves. So at present, this is all that I have got to say. I would like to welcome also, I should have mentioned this before, that Professor Munmun Devi from Guwahati University, Tezpur University, is in fact my co-coordinator of this panel discussion, and she is there in the audience. And I am going to request her to flag off this panel discussion by asking the question to our first panelist.
Hello, am I audible?
Yes.
Yes.
So maybe I'll ask from here itself. Thank you for this opportunity. So let me start the discussion with asking a question to Professor Manjari Ghosh. That you have been like a practicing scientist, you have been pursuing physics for quite some time, like quite a long time. You have also been in administrator post, like you were the VC of this eminent institute. So, like you have been extensively involved in MCQ type entrances, particularly. Like this is the interest for today's topic. So, like, could you please comment on like the necessity, like the motivation, the necessity to look into MCQs through a gender lens? So, what do you?
Perfect. Thank you. I'm going to use some slides, but while I set it up, it's always a pleasure to come back to SNU, and I thank Rohini for giving us this opportunity of a topic that is quite intriguing and very practical. Thanks to Sushanto and Priya Johari for forcing me to come. Otherwise, I was planning to actually sit at home and do. I had a lot of travel to do. So Rohini, as you saw, introduced the topic very well, but from the panel, since I'm the first, I'm going to broaden this quite a bit. And I'm going to take you through some literature that's available, not necessarily in the Indian context, but you see that the generalization works. So that might work. I don't need this. Give it back. So I'll take about 7 or 8 minutes to go through some of the points and maybe give you my view of what this is all about. So thank you very much for doing this, and let's just see where we go with this. Yeah. So general understanding, because I'm the first one, I thought what I'm going to talk about is the idea about MCQ before I come to the gender lens, as Munmun pointed out.
Rupa Manjari, I just want to request you to remind you that you have about 8 to 9 minutes.
Yeah, I will not take more than that. So general understanding is that many studies suggest already that, and this audience, just for completeness, I want to flash it so that we don't get bogged down by this particular point, that MCQs may not be the most appropriate tools to measure students' level of knowledge. We are not debating that today. So people normally would say that it's essential to have a combination of question types to test the cognitive abilities and behavioral assessment. In JNU, the School of Physical Sciences started with the PhD program in 1987. I joined in 1988. And the PhD entrance test, we have gone through back and forth, from MCQ to descriptive questions, combinations thereof, and every time we'll analyze and do it. till we started the master's program in 1992 as the coordinator of the first master's program in physics at JNU. And there, because the pool was large, so essentially we stuck to ultimately MCQ. Devashi should be able to tell you what is happening now. The point is that this general understanding is there, and people would say, given the large volume, the competitive exams in India are used not for real assessment. You don't select, but you eliminate because you have a large volume of people. So, but even for small volumes, and COVID had taught us that exam pattern has changed from descriptive to MCQ because of advantages, right? MCQs are considered objective, easy to mark, etc., etc. So what we all say is that it eliminates the stepwise marking that incentivizes conceptual clarity, right? Because even if your final answer is wrong, you can still be right in your steps and you would score, which you can't really do if you just have MCQs. And in many problems, there is not just one correct answer to a situation, and perspective and thought process of the student matter. So these things are known. I'll not get into it. So just to set the stage correct. So there are, of course, imperfections on top of it. We don't have ideal MCQs all the time. There are non-standardized test questions to trick the students, etc., etc. So we are not discussing that today. Today's context is through the gender lens. And as Munmun asked me, I'm going to actually justify what are the questions and what do you think is the situation, and give my maybe perspective. So study after study has seen that males outperform females on average on MCQ items compared to their relative performance on constructed response items. Now, there are several studies, not all in India. So the questions I'm going to address vaguely, there is not much time. Rohini is already tracking carefully, and we need to hear, with such a beautiful panel, you'd like to hear everybody. So let me just flash the questions and we'll come back to it in the discussion time if necessary. So how to understand and address this issue? So address which issue? The gender disparity, right? The fact that you don't have parity in MCQ results. So is there something inherently gendered? I'm not equipped to answer this question, but I'm going to show you the data towards that. There are no differences in how males and females do math or physics, right? If you do brain imaging, that's what you'd come up with, but then there is an expert in the panel who would probably talk about it. So there could be cognitive differences, but probably not the way you do maths or physics. So we need to have gender data on strategy and preparation for each exam. Is that what is lacking? Risk-taking abilities, when you don't know the answer, can you guess the right answer? Is there a difference? Is there a gender difference in there? Of course, Rohini has already mentioned that high achievers and average performers, you need segregated data, urban, rural patterns and different cultures. The Indian context may be very different from the US or other contexts. So I think these are the things. The first question that I'm going to flash with an old paper that has come out in that probably you have seen, is it because it's something that people have asked me, the underrepresentation of girls, because parents may be unwilling to spend money to send their daughters to coaching classes. This is a parallel industry. These are urban centers, so there could be an urban bias. And is it really true that maybe on girls you're not spending money? I was involved in KVPY from day one, and there in one meeting we decided towards the end of the lifetime of KVPY that we'll make it free for girl candidates. So, but I don't know how many. What was the impact of it? We did not collect enough data to see that. But the point was it was not even available to others. Girls don't quite like to be treated. That's also differently. That was also another point that came. But was that the question? So the routine reports how girls perform better than boys in the state board, CSC, high secondary level exams, right? So how well do they do in more competitive and coveted exams like IIT, JEE, and INO, the Olympiad, for example? So this was a paper done by Vijay Singh and Praveen Pathak. Probably you know who they are already, good friends. So what they found is that the training and skills required to do well in CBSE appear to be largely irrelevant for JEE and Olympiads. You agree probably. Today, this is 2010, 13 years back. So almost all the students who did well in IIT and Olympiad exam went to coaching classes, and these fees were fairly high. They privately gathered the percentage of girls that were taking those enrolling in coaching institutes. In Mumbai, it was like 1/6 of the total students were girls. In other cities, about 1/4 of the students were girls. So it's not totally zero, but still a substantial number. I'm not going to interpret this, but leave you with this thought. So that's the question to be asked. So open-ended versus MCQ are their tests. Of course, there have been 2018, there is a paper that you can see. This is true all over the world. Girls perform better on standardized tests that have more open-ended questions. That's just the data. I'm not interpreting that. The boys score higher when the tests include more multiple choice. Test format explained about 25% of the variation. And this, of course, is something that we need to really ponder about. So what is the reason for it? So the third kind of data that we have, you would ask the questions, if females skip more questions, even when they're prepared and well-trained. That would answer the one point that I made already. There's some studies that were done that it shows that, that females skip more questions on these states undermine their performance. But when a female prepares intensively and trains for the test, although she skips more questions than men, the effect is smaller than in the previous literature. That's something to be noted. We still find differences in the exam performance between male and females, and this gender gap in performance is greater for the best candidates, for the top achievers. So this is the data that I'm confronting you with. There's an interesting side question of what I just said, is imposing penalties when you have negative marking for wrong answers. Does that deter women more from guessing? Because that's also another trick. Now, the key question is that, is it more for women than for men, disadvantaging female test takers? The argument is that when there are penalties for wrong answers, women may be less likely to guess. They may be taking less risk, potentially leaving points on the table. So there is a PNS in 2020 that gives some data on that. So this really suggests that simply removing penalties from wrong answers reduces a sizable gender gap in questions skipped. Now, this is just looking at the data and taking a measure without analyzing why this is happening the way it is. So I think this is really another point. And the last point I want to talk about is gender difference in answering questions. If you're answering too fast, say less than 3 seconds, or you're skipping them entirely. So what does that say? It says less attentiveness. And also, what about it? Can you correlate that to your confidence level? So there is a, last I read about it, I think everybody talked about this article in the conversation that came out in May 2021. It got reproduced in PhysOrg, and it talks about multiple choice exams favor boys over girls. Now, it's an extensive study done, but the findings were boys perform better and gender gap in math scores widened with the share of MCQs in the exam. But the advantage you see are marginal. If you, I show you only one piece of data. This is in performance in maths by gender, red girl, blue boys. So if you look at the proportion of multiple choice questions as what is written on the right-hand side, you can see that blue bars are slightly more on the same, but it's not really a very significant, but it's a consistent one, but not a very significant, variation amongst boys and girls. So they analyze how students approach the answers by tracking the time it took them to respond to a question, as well as the number of questions each student skipped. So if you can identify students who answer questions, as I said, too fast, which does not allow for careful reading of the question, right? So answering questions too fast or skipping them entirely can be seen as a sign of low effort or inattentiveness. So they found there is a gender difference in the approach students took to answering. Boys answer faster and skip more questions when it was all open-ended. However, this difference started to reverse more when more MCQs were in the test. So girls who received an exam with more MCQs were more likely to show a lack of effort than when there are more open-ended questions. Mind you, this more is marginal, consistent, but marginal statistically. So again, there's a data, you can see the pattern and read that article for more details. So you'd like to then sort of correlate that to the level of students' confidence in their knowledge whether that may play a part in their performance. So previous research has shown that girls with mothers working in STEM are more confident in maths, and they're less likely to believe the stereotypes boys are better than girls, right? So it's a conditioning, social conditioning. So they actually did that, and the negative effect of MCQs on girls' performance disappeared in girls whose mothers had STEM-related occupations. So again, one point to take note of. So to summarize, what I'm talking about is the problems are mainly of one, lack of awareness, lack of exam strategy and lack of preparation. And more importantly, as every time we talk about gender issues, is the social conditioning in patriarchal societies, is the lack of confidence, conscious and unconscious biases that prevent girls from performing that well. The two statements that hear all the time: women tend to avoid competitive situations, whereas men prefer competitive tasks, is a myth. This is again the social conditioning. The so-called imposter syndrome involves feelings of self-doubt and fear. All of us have it. Fear that your own skills are not sufficient. So both men and women struggle with this problem, but perhaps more women are affected because of, again, social conditioning. So that's definitely one big part of the problem. But also the second point that I wanted to mention is that we need to move towards an ideal MCQ test. I mean, I don't know when, how we'll do, but for example, GRE, if you look at it, the way it's standardized, but when standardization happens, you have to make sure that there is no gender bias in the standardization process itself. So action points, of course, the other panelists would cover, and I'm eagerly waiting to hear. We need more context-specific gender data and analysis. Regularly analyze the GRE, JEE, NET, test results. Devashish, I know, would talk about some. We need to standardize the MCQ test without bias, as I already mentioned. You need to sensitize, increase participation and engage of women, and meetings of this kind definitely helps towards that goal. We need to rely on science to understand gender differences when they are rationally. And I think with that, I just stop, Rohini, within the time allotted to me, and I'll be eagerly waiting for your questions on this. Thank you very much.
Thank you very much, Rupa, for giving a very clear introduction to our discussion and setting out the different points. So now I thought I would like to ask a question to my next panelist, and me and Moon, we are taking turns in asking these questions. So I would like to ask my next question to Devashish Ghoshal, that as I already mentioned, Devashish, you have a long experience as a theoretical physicist who works in the environment of a research institute as well as a university. And you have experience with entrance tests of different types where students have been selected for a career determining, choice. So I would like to ask you to tell us about the gender distribution, if you have available to you, of the success rates for the different examinations for which you have some knowledge. And then can you comment on your perception on why the numbers show this trend, and what are your thoughts about bucking the trend? I am sure this is a very long question, so I would request that you take 9-10 minutes to address whatever part of this question that you can, and then the rest we will take in during the discussions.
Good afternoon. I hope I'm audible. So, thank you, Rohini, and the other organizers for inviting me to this very distinguished panel. It's true that I have worked at the National Research Institute, but it's quite a while ago now. And I'm not really familiar with the recent statistics from the research institutes, which Professor Kanikar will probably talk about. For the last decade and a half, I have been working at the School of Physical Sciences, teaching physics at JNU, which is actually a microcosm reflecting the diversity of our vast country. Our students, as in most universities, come from all corners of the country through our own entrance test.
Yeah, I'm sorry. I'm sorry. Can I interrupt? I think the audio level has to be a bit higher.
Is it better now?
Yeah.
Actually, I would like to say that if you can go to the dais, because
Yes, yes.
Rupa Manjari was perfect. I mean, her audio level was perfect.
Is it better now?
Yeah.
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 Okay. Okay, so the receiver came to me. Yes, so our students come through our own entrance test. And as I said that, I realized that this statement is actually requires updating, because until about 2 years ago, that was the case. Then our previous vice chancellor took some unilateral decision to sign us up for the so-called common entrance test for the universities. And so the entrance test is not only JNU's, but a combined national level entrance test. So that is the one way of entry for our master's and PhD program. And in addition, for PhD, major route for entrance is the CSIR UGC National Eligibility Test, which is also a sort of license for faculty position in our university. So people need to clear that test with a certain cutoff to be able to teach at universities. So you have asked me 3 questions, which probably will take a little longer than the time allocated in the first pass at least. So I will concentrate on the statistics related to these 2 entrance exams. I requested both CSIR and JNU to share some statistics, and both have given me some some statistics, shared some statistics from the records, although it's not so comprehensive. And I'll let the statistics do the talking in the first round. If there is time, I'll try to address the other questions, but then we can always come back to that later. There's a larger question of MCQ that Rupa mentioned, which is, nobody would like this as a method to test students in an ideal world, but due to many compulsions, mostly the question of large numbers, that this method is forced on us. But even, I should say that even within the MCQ-based tests, there are many different ones, and a professionally designed MCQ test will be less flawed than other such MCQ tests. So most of the time, we have a group of amateurs who are good at teaching and research, but have no experience in designing questions suitable for entrance exams, not just MCQ, but any kind of exams that will be suitable at that level. And we just have to do that, or rather forced to do that. And that is one of the things that should be looked into and should be changed. So the national testing agency that has been set up is presumably with that aim, but it is ill-equipped at present, in its present form, to do that. In contrast, the graduate record exam of the US, which many universities adopt, is conducted by an agency called the Educational Testing Service, which has dedicated team for this kind of exams. So now let's come to the subject that we have today, which is the possible gender bias of MCQ. And naively, one would think that MCQ tests are objective, so it should be free of all kinds of bias. So much so that our previous head of the institute thought that it would be the best way to test students for entrance to PhD programs in subjects like history and English literature and sociology and political science. So these tests are at present conducted through an MCQ mode. Of course, even for science subjects, physics is mainly our concern today. This is not the best way to test a student. A student would be doing a problem and then may make a small mistake towards the end and get a wrong answer, which is not ideal for this kind of test. So you would think that this is objective, but it is not so. In fact, the first thing that comes to mind is that it is certainly biased against those with better linguistic skills, because the questions are framed in a language which may not be the most familiar language of the student who's taking that test. So coming to the statistics, I have requested CSIR and who have actually given me the most comprehensive statistics. So I'll start with that. So this table shows the last several exams, the total number of students who applied to take the NET exam in physical sciences, not applied, rather appeared, which is almost the same as who applied. And among them, the distribution of number of male and female students, you will see that this number for physics is roughly between 0.45 to 0.5. In one case, it is 0.52 almost. So it's roughly 50% or slightly less than 50% of the students who write this test. But when it comes to qualification, you'll see that there is a significant drop in the number of girl students. That is, this number is about between 25% to varies between 25% to, in the best cases, about 31%, and didn't do any better in physical sciences. And in all cases, you will see that there's a drop. I don't know if drop is the correct word or not. What I have plotted in this purple in the column there, which says percentage drop, is the fraction of percentage of female students who qualified as compared to the percentage of female students who appeared in this test. So that number goes down, and it's better than 50%, but less than about 60-65%, which is quite a significant number. I'm just going to present statistics. I'm not going to come into the analysis of this yet. And I'm not really qualified to do that also. So the same data in graph here, and you see there is a substantial gap between the two. The same again in bar chart. The situation in all STEM subjects is roughly the same. Mathematics is actually slightly worse than physics, if anything. Even though on one or two occasions there's some aberration in the statistics, it's significantly worse than the performance in physics. If we go to chemistry, the situation improves a little compared to maths, but compared to physics, it is slightly better, but not, again, there's only about 10% better, I would say, not so much more than physics. Earth sciences is somewhat worse. And finally, in life sciences, where we know that there is quite a large number of girls who take the test as well as qualify, the situation is better, but even then, it is not 100%. That is, there is still a drop, which is about 80, varies between 85 to 90%, which is also significant considering that life sciences is something which is taken by a very large number of girl students, and there is also among the faculty members, there is quite a large number of women scientists who are involved, I'm sure, involved in the designing of these tests and all. So there is some sort of unconscious bias that has certainly gone in, even with a very significant participation of women faculty. So this is the number, these are the numbers, and this is a comparison for physics, maths, and life sciences. The first one is the fraction of girls who appeared, and the next one, the second column is the ones who qualified, first physics, then maths, and then biology in the different exams. And you will see this is visually confirming what we already talked about, that the situation in physics and maths are comparable. In biology, it is somewhat better, even though there also it is not as good as it should be. Now I got some data from JNU. Unfortunately, this data is much less comprehensive. And for the last 3 years, of which 2 years data are from the common, actually probably all 3 years data are from the common entrance exam test. So I could not get for different subjects. I could not get for the students the number of students who appeared. These are the number of students who finally took admission to these programs. And I would imagine that the fraction of students, girl students who write these tests is similar to the ones that wrote the NET exams. With that assumption, we'd say that about 45 to 50% of the students who were girls who took this exam. And you will see these numbers here. This PCM is the combined for physics, chemistry, and mathematics, because we have a school of physical sciences which have all these 3 subjects in them. And in the PhD program, significantly the number of girls are less, except the last batch where the number of girls are more. And in MSc, the number of girl students were in total was quite good, I would say. In fact, it's better in the last year it is worse, but the 2 years before that, it is more than the number of boys. In biology, in contrast, of course, the numbers are higher, the number of girls are higher. And I have shown the same data here. This is for first set of data, first 3 are it's organized by the number of years. I'm afraid that my skills with data handling with Excel is not that good. So let me explain. The 3 columns are for the 3 years. The first one is for PhD in physics, the fraction of the number of male students. The next column is the number of female students for PhD in physics, chemistry, and mathematics. The third column is the same for boys in masters, and then for girls in masters in physics, chemistry, and mathematics. And the the last set of 4 columns have the same data for life sciences, which also has actually combined the School of Life Sciences, the School of Biotechnology, and the Center for Molecular Medicine, all combined. And you will see that the number of girls are consistently higher. In fact, for masters, the number of boys are actually is much, much smaller than the number of girls in these disciplines, which is also an imbalance and probably should be looked into. So I have got these data from these organizations that I mentioned here, so I'd like to acknowledge them. And so these are my slides, and I'd like to just quickly flash one slide on the GRE data, which is the number of students who took the GRE exam. Blue are boys, red are girls, and you'll see that for physics, the number of boys is almost twice as the number of girls, and in life sciences, it's quite the opposite. The data for students who qualify is not really available because there is no real qualification here. And GRE has not only just MCQ, but also different kinds of tests. So it is difficult to get there. They have this organization that conducts this test. They have extensive data in terms of numbers, with given the mean number of mean score of these students in different kinds of tests that they can conduct, quantitative, qualitative, as well as the MCQ type questions, so that you can see by going to their latest report on their website. This plot shows actually the number of men students have recently overtaken the number of women students in GRE. And that is mainly due to the fact that very recently the number of students from India, which is the second largest number of students who take the GRE exam, have almost caught up with the number of students who write the exam from the US. In the third position is China, which is much smaller in number. And in India, the number of boys who write this test is almost twice as large as the number of girls who write this test. While in the US, it's about boys are about 60%. Boys are about 40% and the girls are 60%, or maybe 65 to 35% is the distribution of boys and girls. So I think if I've finished my time in this round, I would keep the other questions on hold. Is that okay, Rohini?
Yeah, I think Debashish, thank you very much. I mean, your slides are there, and I guess we will come back to a question after some of the questions which you could not address right now, after everybody else has also presented their points, because I think there is going to be some implication, the answers are going to be intertwined. So thank you again. And
I could just add that, although I don't have systematic data in physics, the master's class that I teach in this year, there are 34% girls. Last year was 53%, and the year before was years before were 46% and 41% respectively. So the number of girls students is quite significant at the master's level. So, thanks.
So this actually, I would, anyway, we will come back to this point also. because I have some comments on that. But right now, let's move on. And Munmun, can I request you to ask the question to our next panelist? That is Nisim.
Yeah, so now the next question goes to Professor Nisim Kanekar. So
Excuse
who
me.
has been an astrophysicist
Excuse
working
me.
for a really long time, and he has been
What is the
involved
point,
in,
Nisim?
am I audible?
Yeah, it's okay. I was just about to say, please unshare the screen.
Okay.
Okay, so he has been in charge of entrance exams at the NCRA TIFR, and he has analyzed some gender aspects of the results of different entrance tests and procedures. Some of them are MCQ based and some are not. So I'd like to request you to share some of the lessons you learned. Then what may be the possible reasons from your experiences? Like since there are some trends for the two genders, and then talk about the processes that you think can be put in place to level this scenery. So over to you, Professor Nisim.
Thank you, Munmun. And thank you to both Munmun and Rohini for organizing this. I think it's really useful and important. And actually, I should also thank Rupa for a superb first talk. I got these data, so I'll be talking about 3 different ways of PhD selection. One via the Joint Entrance Screening Test, or JEST, which is used by about 25 to 30 institutes across India as a pre-selection for PhD selection. The second, the TIFR GS test, which is used by TIFR and various centers of TIFR. And finally, a completely different approach to selecting students for the PhD program, which is the Visiting Students Research Program at the National Center for Radio Astrophysics, which does not use an MCQ test. So I'll show you results for the 3. And the first 2 are, of course, based on MCQ tests. So let me just share my screen if I can. Maybe I'll just do desktop. Can you see my screen?
Yes.
Excellent. Right. So these are now, I'm going to just jump straight in, and I'm going to show you 3 figures and with some associated commentary. These are data. The first slide is data from the Joint Entrance Screening Test, which, as we know, is an MCQ-based entrance test. And roughly, it's for physics and computer science. And these data are for physics alone. I've excluded the computer science people. And typically, some number between 13 and 20,000 people have taken this test over the last decade. So these are data now. Each point over here is a measurement for the year listed below. So 2012, 2013, 2014, and so on, all the way up to last year. And institutes across India use JEST as a filter to pre-select people or select people for follow-up processing, which includes, it could be interviews, it could be an additional written test, but JEST is the first stage. If you don't clear JEST, you basically don't get into the next round. The second thing which is important is that there are JEST ranks. So typically some number between 500 and 1,000 people clear JEST every year in physics, but many institutes will only call people who are in the top 100 or the top 50 or the top 200 ranks. So being high in the JEST ranks is important. And most institutes will actually use the JEST marks as an input, as a direct input to the selection, to the final selection, in addition to simply calling people for for the next stage. So let's get right in. There are 4 types of points over here. The red stars show the female percentage or the female fraction relative to the total of people who applied for JEST in any given year. So for example, in 2012, the female fraction was approximately 30% who applied, who registered. And for JEST only, I've actually done a separation to demonstrate that there's not much effect between the registration and the actual writing. So the blue circles are the people who wrote JEST. And you can see that they're very close to the red stars. They're within 1% or 2 in all years. You can see a slight drop in 2021 and 2022, but typically it's more or less bang on. And so the typical number, the typical female fraction over the last decade is something like 37%. The median is about 37% of people who wrote JEST. So that's the blue. You could draw a blue horizontal line over here and you get about 37%. The orange squares over here is the female percentage of people who cleared the exam, which means that they got a GEST rank. And that rank could be any number from 1 to, let's say, 1,000 if 1,000 people were selected. And what you see immediately is a sharp decline from the blue points in every year, a sharp decline from the blue points to the orange, blue circles to the orange squares. And that drop is about 15%, 37% to about 22.5%. So the median over here is about 22 or so percent. The median here is about 37%. So that's the first pass, that even just getting a rank is causes the female fraction to go down by about 15%. What is equally interesting, or maybe more interesting, is that now if you look at the people at the female fraction within the top 100 ranks, and here what I've done is that I've included top 100 in PhD and top 100 in INT PhD. People are applying for both the PhD and the INT PhD. So this is effectively 200 people or 200 ranks approximately in every year. And what you see there is shown is in the black pentagons, you see an even sharper decline. And you're down to something like 14, 15% for people in the top 100 ranks for the female fraction. So we've gone from about 37% at the writing stage to about 14% in GEST at the top 100, top 200, top 100 in PhD and top 100 in PhD stage. So there is clearly a sharp decline in the female fraction in GEST, and the decline is even sharper for the top candidates who, remember, are going to be called for the next round in most institutions, and many institutions will not call people below the top 200. So the effect is, one should really think of this effect as being on the average between 37% going to about 14%, which is by any metric, I think, a large effect. So that's the GEST exam, and that's over the last decade. And I should mention that these data were provided very kindly by Ravindra Reddy from IMSC. The next data set is for the TIFR GS entrance test, again for about the last 12 years or so, 11 years, 2011 to 2022. Many of these data were provided kindly by Shubha Tule from TIFR, who's done a similar analysis. And here I have just not shown the points where people who wrote the test, because it doesn't make much of a difference. The application and fraction of people who write the exam is about the same, within 1%. Again, the TIFR GS entrance test is an MCQ-based written test. The number of people who take it is typically of the order of 5,000 to 10,000 every year, in different varies across the years. And this is used to select people. Earlier, it used to be used to pick people directly for interviews. And more recently, there is an additional written test, which is now not MCQ. But there's an additional written test, but the bulk of the people being picked are based on the MCQ test, and only a subset of those who are selected then go to the next stage. So again, same philosophical issues as with GEST, and similar pattern. So again, the red stars are the application stage, and you see that the female fraction is about 42, 43% over the last decade. And the next step is the orange squares, where these are people who are called for the interview. And you see again the same sharp decline that you saw in GEST. The median over here is about 15% again across the last 11 or so years. And the black circle, the black pentagons, now we have additional information, because remember, in GEST we didn't have the information about what happens after the interviews. And that's because each institution will carry out its own interviews, its own additional processing. For the TIFR exam, we do have that information about the interviews, and that's shown by the black pentagons. And you see that in some years, the female fraction actually is lower after the interviews, is lower than that which appeared for the interviews. In other years, it's higher. There is a little bit of a trend over the last 5 years, 5-6 years, that the female fraction after the interviews is lower, but there are years, for example, 2021, where the female fraction after the interviews is actually higher than before the interviews. So I would say the effect of the interviews is not quite clear, but it's clear that there is a drop in the female fraction from about 42% at the application stage to about 15% after the MCQ test. And this is, again, as you can see, very similar to the numbers that we had in GEST. In TIFR, the number of people picked is much smaller. It's about 200 or so people who are called to TIFR. While GEST, of course, the number of people picked is much larger. It's more like 1,000 people at the MCQ stage. So it may not be surprising that we see an even sharper decline in the TIFR thing. It's more comparable to the top 200 people in jest. So about 40% to about 15% after the MCQs. So that pattern is the same in both in both jest and TIFR. And again, let me emphasize, this is TIFR physics. If you like, I can show you results for TIFR biology later. The third entrance approach is the NCRA Visiting Students Research Program, which is a research program, a summer research program for masters and undergraduate students at NCRA. And the selection here for the program is based on the application material, which includes a statement of purpose, your grades, your motivation statements, and reference letters. So it's not an MCQ selection process. And the PhD selection process, which is now based on the number of people who have been selected for the VSRP, which might be some number between 4 and 10 every year. The PhD selection process is based on a seminar and interviews. No MCQs anywhere involved in this process. And what I've plotted over here, so now this is over the last 12 years in NCRA. It's simply the female percentage at the application stage, the female percentage at the stage of the VSRP selection, and the female percentage at the stage of the PhD selection. No MCQs in sight, and this is an integrated result over the last 12 years. And what we find is that the application stage, the female percentage is about 35%. At the VSRP selection stage, the selection for the program, which is based, as I said, on the application material and reference letters, things actually improve. Although, of course, there's Poisson errors. These are completely consistent within 1 sigma. And we are at about 38%. At the PhD selection stage, the female fraction actually goes even higher, slightly higher than 40%. So basically, and again, I should emphasize, although it looks like this is increasing, this is completely consistent because of Poisson errors within 1 sigma with the application percentage. So the error bars on this are plus approximately 15 and minus approximately 11%. So it's about 41 minus 11% and plus 15% once you put in Poisson statistics. So the message I like you to take away from this is that there is no drop fairly clearly in the female fraction from the application stage. And this is more than a 3 sigma result compared to the 15% that you see at jest and TIFR. So therefore, this is one example of a selection which does not use MCQs, but which does use interviews and seminars. And seminars are, for example, probably a better metric of people's ability to do research. And that seems to not show any effect on the gender ratio. So I guess that's all that in order to stay within time, I think I'll stop over here. I'm not sure if, Munmur, would you like me to answer some of the other questions? These are the broad results that I have from the data. I think the data show fairly clearly that MCQ tests have a strong negative effect on the female fraction. And more importantly, I think we have tried a different approach towards selection, which does not have the same effect. And we do not see any difference in the quality of students from the VSRP to the other entrance exams at NCRA.
Nissim, thank you very much. I feel that in view of the time the remaining points we asked you to comment on, we will take them up after the other two panelists have had their say, because I also feel from having talked to you before that there might be again the points you want to make on the other two issues are going to be intertwined with also the points I think that some of the other panelists might be making.
Sure. Yeah. Thanks, Rudy.
Yeah. Thanks, Nissim. Thanks very much for this very clear data, because the question I think that we are going to have to ask, and that's what I'm hoping in the discussion to be discussed, is that you are giving us one lesson where MCQs definitely have an impact. Now, the question is, if they are indeed for some level of selection, we have to go via MCQs. What should we do? And I think that is where I wanted some thoughts from you, but I think we can take it up during the during the discussion and interaction session with all the students. Because already I see in the chat many questions which are having a bearing on the kind of points that you people want to make. So let's move on right now, if you don't mind. Okay. Thanks for this. So Munmun, maybe can we invite the next speaker, which is Kate, and I will give you the sort of charge that you please invite her and pose the question. And a request to Satya that Please put the spotlight on Kate, please.
Okay, so hello, Professor Kate. Welcome once again. So now the question is to you that, like, I mean, you have been involved in as an educationist in for like MCQ tests, and also you have like explored it a bit more. Like your article for girls, just not scientific enough, which was published, actually brought out very interesting aspect of gender dependence on of the answers to the questions in MCQ tests. So, and you have also like interacted with some of the Indian experts at HPCSE. You have started a collaboration on like studies on the gender aspects in some of the MCQ tests in India in particular. So, I'd like to request you to share your thoughts on the gender aspects of MCQ tests that like you have gathered in these these Indian oriented or any other studies, and perhaps some thoughts on whether and how they can be tackled. And also, like last but not the least, do you have any comments specific to the Indian context? So over to you, Professor Kate.
Thank you. Thank you very much, Mainmit. And thank you very much, Rohini, for inviting me. I'm very flattered to be invited along to contribute to the panel. So I guess the question that I wanted to address was, do MCQs contribute to gender bias in physics assessments? And this is something that I've been looking at for almost 20 years now, actually, since I was the director of the Australian Science Olympiads physics program. And when I started in that role, the very first time I showed up to meet the group of students who had been selected from our qualifying exam, which is roughly equivalent to your national standard examinations for the Olympiad programs in India, we take 24 students from about 1,000 that do the exam, and I showed up to the residential, and I think there was one girl out of that 24, and I was absolutely horrified. And so I talked to the staff who'd been involved for some years and said, what happened? What went wrong? How is this the case? And they said, well, it's a bit low this year, but we don't usually get more than 2 or 3. And given that roughly 1/3 of the students that take the exam are girls, there's clearly some sort of filtering effect going on with that qualifying exam. So from around about then, we started looking at that exam, we started making tweaks to it. I've also looked at, as you mentioned, the equivalent exams in India working with Praveen Pathak. And I teach at UNSW Canberra. So I use my own students as guinea pigs, basically. I test out questions on them. We've run focus groups where we've seen a big gender gap. We've talked to our students to try to figure out, why has this happened? You know, what is the problem with this question that it's doing this? So, I'm not quite sure if you're seeing this bar across the top. Maybe if I move that down the bottom. So one of the things we did was we looked at the gender gap on the multiple choice section of the exam. So the Australian Science Olympiad physics exam, it has 2 sections. When I first started with the program, it had 20 multiple choice questions and then 4 written answer questions. And the marks on the written section are generally very low because they're very difficult questions. So the multiple choice questions were disproportionately contributing to students' marks, even though the bulk of the available marks were not there. One of the first things that we did was we looked at the gender gap in the 2 sections, and the gender gap was much larger in the multiple choice sections. So that was the first thing that we did. We reduced that down from 20 multiple choice down to 10 multiple choice. So the relative weighting of the multiple choice section came down, and that immediately had a positive effect. We had more girls as soon as we did that. But we still weren't up to about 1/3, which is what we were hoping for or close to. So then we started looking at question by question. What was the gap on each question? So the graph here is a frequency distribution. So this is how many questions, and this is the gap being the male facility, so the fraction of boys that got the question correct, minus the fraction of girls that got the question correct. The green line indicates 0. So these are questions that had no gender gap. And you can see out of 110 odd questions, there were only 4 of those. And there were very few that had a gap the other direction. So on the negative side, these are questions where girls did better than boys. On the positive side, these are where boys did better than girls. And the average was 0.06. Now, that may not sound like a big deal. 0.06, only 6% different. But when you are taking 1,000 students and you're choosing 24 of those, any little difference like this, especially when you're looking at the top end of the distribution, that's what leads you to having very few girls actually being selected and able to go on to the next stage. And I actually want to point out the girls that we did get, they were just as likely to end up on the team representing Australia at the Physics Olympiads as the boys were. So once we got them into the residential, into the training camp, they performed just as well as the boys. Any gender gaps, they simply weren't there at that point. So things I want you to note from this graph. There is a spread across here. There are questions that have a very big gap. There are questions, very few questions, that have a negative gap. And in fact, these are questions that we were kind of experimenting with to see if we could get a negative gap in one case at least. And there are a lot of questions that have kind of a middling size gap here. So the next thing that we did was all right, make sure I can get to the next screen. There we go. Was we tried to find patterns. We looked for what gives us a big gap, what doesn't give us a gap. And we tried a bunch of different ways of classifying the questions. And eventually we came up with this classification scheme. So we looked at what was the content being examined in the question, what was the process, so what did students need to be able to do? Did they need to read a graph? Did they need to do algebra? We looked at how the information of the question was provided to the students. Was it primarily as words? Was it primarily as equations? Were there diagrams that were absolutely necessary for them to be able to read? We looked at context, so degree of abstraction through to physical experience. There has been work done by Laura McCulloch from the US where she played with coming up with contexts for questions that were more feminine. So instead of, for example, shooting a rifle, she had a teddy bear being thrown, things like that to look at projectile motion. But she really didn't find that that made a difference. Some gaps went up, some gaps went down when she did that. There was no consistent pattern. So instead of doing that, we instead went for degree of abstraction. And then we looked at difficulty, which is not a particularly objective thing. So we tried to make it something we could effectively count. So number of concepts, or the number of steps, or the number of spatial dimensions. So we came up with a difficulty based on that. Where there are words in red, these are the things that tended to give us large gaps. So girls did not do as well on questions to do with kinematics. They were fine with reading graphs, fine with doing algebra and calculations, but complicated diagrams, especially in multiple dimensions, they tended to give us larger gaps. Similarly with presentation. And degree of abstraction from, your kind of bare bones mass on a spring through to physical, something that they may have physically experienced. We found that where it was something that a student might have physically experienced, that tended to give us larger gaps than when they were more abstract, bare bones textbook style questions. So with that in mind, when we looked at a question like this, which we had used, or which had been used in the past, so this was a multiple choice question. I haven't shown the answers here just for clarity of reading, but basically it's a ball being thrown. So the diagram is important. It shows the trajectory. It's about projectile motion. And then it's comparing the velocity and the acceleration at point A compared to point B. So there's a spatial element as well. You need to be able to think in 2 dimensions with this one. And this is a nice example of how those factors can combine to give a large gap. So this is that large gap question that you could see at the far end on the previous graph. So 0.27, big gap. So we found that we got reasonably good at being able to predict what sort of a gap are we going to get, but not always. So this is one that, and I'm sorry, I know I'm kind of getting towards my 9 minutes now, but I thought I might just quickly share this one with you. So this was a question that we had used with our undergraduate students. The first time I read this question, I wasn't reading very carefully. I was reading very quickly. I was skimming it because I was kind of busy and had a lot to do. And there were a lot of plurals here. And so I was miscued and I misunderstood the question. And I thought, well, maybe it's not just me. Maybe girls are doing that too. So we rewrote it without the plurals. And as you can see, the gap went from 0.28 to 0.26, which given the sample size for the second one is no different. Statistically, not significantly different from that 0.28. So then we did what we should have done in the first place. We got a group of students and we said, tell us how you're reading this question and tell us why you're choosing the answer that you are. And if I had more time and if we were in person, I would offer a prize for the first person to spot the difference between this version and this version. But given that I'm just about out of time, I'm going to point it out to you. We changed one word, the word just. Air resistance just balances the force of gravity. In the correct answer, we have the word just. And it is technically correct because the air resistance is gradually increasing to balance the force of gravity. We take away the word just and the gap drops significantly. So one word, sometimes one word can be contributing significantly to a gap in a question. Now, I'm aware that I am out of time, so maybe I'll hold off on talking about the data set from India until after the final speakers had a chance. Is that okay?
Yeah, but it depends. I mean, if it takes you 1 or 2 minutes to...
Yeah, I can do this in, I reckon, 1 or 2 minutes.
Yeah, please, then I think...
Okay, so the lovely thing about the data set from India is it's huge. It's, 30,000 odd students. So we can do, statistics are nice. And this is what I was talking about before. These are the boys up here at the top end. You're only selecting from up here. So you're not getting girls. And the number of girls on the Indian teams for the International Physics Olympiads is much lower even than the ones from Australia. I think Praveen went back and looked and it was something like 4 in 20 years. And it's because of this. And what I want to show you, this is the negative marking thing, which was mentioned by at least one of the other panelists. If we look at the facility, so the fraction of questions answered correctly by males on the first section of this exam, so there are 60 multiple choice questions with negative marking. On this first section, the facility of the males is 0.21, the facility of the females is 0.17. There's a gap, but it's not enormous. But now look at the score. The score for the boys on average was more than double the score for the girls. So clearly there's an effect here, which is not just about knowledge and understanding. This is about test-taking strategy. So, and I think this is at least somewhat linked to girls not having as much access to coaching colleges. They're not being taught strategies for multiple choice the way that the boys are. The second section where there is no negative marking, you can see again there's a gap. But of course, because there's no negative marking, the ratios here are the same. So I would suggest that negative marking is contributing to this filtering effect that we saw from the last speaker, where the number of girls applying the fraction of the girls applying is much higher than the fraction of girls getting through. And simply taking away the negative marking, which was done a few years ago in Chile, because they used to do the same thing, they eliminated it and it has actually improved their female participation. So I would definitely say that multiple choice questions can and often do contribute to gender bias. Right, and I will stop now, and I do apologize for going over time.
Thanks very much for this, information of original research on essentially the subject of our discussion and giving your considered opinion based on the data. And I hope that we will have some time at least, and hope you can stay with us for the answers discussion part, because we have started about 10 minutes late and we might get a little more pushed beyond our stated time. But thanks again. So again, Munmun, can I request you to ask the question to our next panelist? Because you seem to do a much clearer job than I do. And again, I request Satya to move the spotlight to our next panelist, that's Nandini.
Okay, so our next panelist Professor Nandini. So once again, welcome to the discussion, to the panel. So the question now goes to you. Actually, you have started, you have trained, you got trained and worked as a theoretical physicist. And then you moved to another field of brain research, and you have worked in cognitive processes. So now it will be very interesting to see this entire topic or the entire context from an entirely different point of view. So now that's why we now go to you, that because it gives you really unique perspective than the things that we have been discussing till now. So we would like to request you to comment on the gender aspects of cognitive processes, and what's your take on the gender difference that is seen in MCQ test. We have already seen from the data and the previous discussions. So over to you, Professor Nandini.
Thank you so much, Munmun and Rohini. And at the outset, I have two confessions to make. One is I did not move from physics to cognition because physics scared me off. I thought it gave me a unique perspective to look at problems in other areas. The second confession I have to make is I do not work in the area of gender bias, but was intrigued by the question. And when Rohini sort of came forth with the idea and encouraged by Nilima Gupte, I figured I would try and look at the research a little bit and share some interesting perspectives, which to some extent have already been touched upon, which makes my job a little easier, but maybe I can provide a little more basis for why that might have happened. So let me share a few slides with you, which could probably help establish this context. So I work now at the Mahatma Gandhi Institute of Education, where I look at designing more of programs which are inspired by neuroscience. And at the outset, while there have been at least 35 papers that have been published to show that there are no neurobiological differences in the way men and women or young boys and young girls learn mathematics, I thought it'd be only fair for the sake of completeness to look at the most recent study in this area. So this was published in 2019 in Nature Science of Learning, and it looked at the results of the TIMA test, which is the test for early mathematical ability in boys and girls across ages 3 to 8. And on the left, you will see scores of boys and girls, girls in red, boys in blue, a distribution of the scores. And on the right, you can see across ages as the scores that are distributed. And at the bottom, you will see brain images. So the IPS is the inferior parietal sulcus, which is really involved in mathematical processing. The prefrontal gyrus, which is the prefrontal cortex, which is this part of the brain that is participating, and the MTG, which is the middle temporal gyrus. So these are all areas that participate in number processing and doing arithmetic functions. And what the authors wanted to look at was to see whether there were any differences in terms of neural maturation between boys and girls, or any differences in the way they use different parts of the brain. And an overlap shows that there are absolutely no differences. So no area that stands out differently between boys and girls as they are learning mathematics. So hopefully we can get that out of the way. But in the process of looking at this, I actually realized that there has been a fair amount of work in looking at this difference in between males and females in test-taking strategies. Okay. And I looked at, again, a recent paper that was out in 2019, which looked at the completion of a test as a cognitive task in a given time period. Okay. And they defined a test-taking strategy as any reason that leads a student to answer a question in an order that is different from that what is presented. Okay. And they looked at 5 factors. And I will primarily focus on one, though, but I'll just summarize the results of the other. So in terms of time management, there is a good amount of research to show that females do better than males. Planning too, they do better. Motivation, female students actually have been found to exert higher effort even in non-incentivized tasks. Okay, testing effort, which is what this study really focused on, actually showed much more sustained performance. But here's where it was really interesting. Willingness to guess. Okay, males were found to be much more willing to take risks as compared to females. Okay, and so I wanted to go back to an imaging study to see where did this arise from, and because this is of great interest even to economists and people in management. Okay, so I'm going to very quickly over the next 2 or 3 minutes run you through a fascinating imaging study that was done with males and females who are required to take risk. Okay, so it's a very well-known risky gains task where you have to perform a key press and you have to decide a safe or a risky response. So for each trial, you are offered 20, 40, or 80 points in a fixed sequence. In the decision-making, 20 points is always a safe response. Okay? But 40 or 80 can be a risky response in the sense that you could either get a gain or get a loss. Okay? Now, when they looked at the results, they found that the behavioral data showed really no significant differences in terms of the rates and the response times. However, female participants made many more safe responses, especially so after getting a punishment on one of their previous responses. Okay. And then when they looked at brain activity and compared differences between males and females, they found differences only between females and males. So there was additional activity in one area of the brain called the right insula, okay, which is involved in emotion and stress, okay. And this is activated when women actually are activated in women when they are doing this task. Not only that, it correlates with the rate of risky responses, thereby confirming for us that taking a risky response is stressful for females. Okay, this has been followed up by multiple studies, and now there are about 150 papers that have gone on to support that risky responses are, there's a clear difference in the way men and women process this. Okay. Now let's look at this willingness to guess in 2 or 3 other contexts. The Economist started looking at this way back in 1983 and showed that there is a clear gender bias where boys are doing better than girls in multiple choice, but girls are doing better in descriptive choice questions. And in 2014, Baldiga published a paper on the willingness to guess, okay, which again showed that what Kate just talked about, that the moment a penalty is imposed, the number of responses that women make are much lower as compared to men. Okay. This has been studied further very systematically by a group in Israel and way back in 1991, where they looked at responses on 5 tests: numerical mathematical abilities, spatial subtests, mechanical abilities, verbal fluency. And they found 2 factors. One is females tend to omit many more responses as compared to males on all tests. Okay. And the second, when you introduce permissive questioning, that is guessing, there are actually, the effect does not go away. Males guess just as much. And the moment there is permissive questioning, women guess even less. But however, when you correct for this, the moment you correct for this, there is actually a way to explain this, which is a lot more consistent. So though the effects are small, they are very consistent in the fact that the guessing behavior does explain the difference between males and females. So I want to stop this here and say that are males performing better in MCQs because they are guessing more? And to end on the note, I want to say this is what my MSc class looked like when I was doing my master's. There isn't that big a difference then, at least between boys and girls doing a master's in physics. Thank you so much, Rohini, for the opportunity. Thank you so much, Nandini. And sorry if I somehow conveyed that you decided to leave physics because
No, you didn't. I just wanted to
I
clarify.
didn't. I mean, it was clear to most all of us that physics was not scaring you. I mean, we know you for a long enough time. I mean,
I just thought, given the situation, I should state that.
It actually proves the point that once you do physics, you can do anything.
I agree with that.
So here is the physicist in me. Okay. So thank you very much. So to begin with, let me first thank all the 5 panelists for making very, very interesting points and everybody bringing, a completely new dish to the table, as it were. Because Rupa, thank you very much for setting out the stage and excellently covering all the points. Then both Debashish and Nissim, I really want to thank you for presenting the data, but Nissim's data, since it corresponded to this study of smaller institutes, was quite, they were actually clear trends, and there's already in the chat box, there is a lot of discussion. But thank you very much for the long period over which you have presented the data. And Debashish's numbers for the CSIR exams are actually quite revealing to me, given the fact that I would have expected for biology, if anything, given the numbers at JNU and given the numbers I see at the institutes, I would have expected the acceptance rates even in CSIR exams for biology skewed towards women, but they aren't really skewed towards women. So there is something MCQs are contributing to that in some way, I guess. And Nissim's point, which was clearly made, that MCQs seem to be having an impact in gendering the tests, rendering a gendered color to the tests. So I would like now actually to do the, I'm hesitating, but since we are now 5:30, I would first like to begin by asking, reading out a few comments that are there in the chat box for the knowledge of not just the panelists, but also the audience. And then I'm going to, in fact, ask people in the audience to raise their hands, as well as I would want to read out a few questions that were already being typed in the question and answer sessions, which I will then pose to the different panelists. And after that, actually, I want to go back to all the panelists again, and maybe I want to ask Nissim and Debashish about their opinions on the, how can we strategize that, given the fact that we might have to live with the MCQs, can we strategize somehow to help women to improve on their performance in the MCQs? And that would be the end. So let me begin first by actually reading out a few comments from Professor Ravinder Kaur. She is actually a faculty in IIT Delhi, and she works in education. And in fact, she writes, and in a continuation to comments I had made, that more girls are now appearing from the appearing as well as qualifying in the JEE advanced exams. And the other point, which was very interesting, that she points out, is that some earlier work which was done at IIT Delhi showed that irrespective of the rank and the scores, the girls that joined IIT Delhi after they were selected, they did much better once they were at IIT. So in fact, compared to Kate's experience, where she said once they were selected, they all did equally well. In this case, actually, girls did even better. And here I can add a personal sort of note that when I was in IIT, we were 52 girls, maybe 50 girls in a total population of 1,000 and students, 1,200 students. And I think from among some 10,000 male students over a period when distinguished alumni were chosen, Indian Institutes of Technology choose their distinguished alumnus. So even if we girls were only 52, about 10 of them, in fact, got the Distinguished Alumnus Award compared to 50 out of the 10,000. So the ratio of people who were really at the top among the girls, even if they were small in number, was much higher for the girls. So that is kind of also with Ravinder's comment that they do much better. Then she also points out that there were fewer negative marking questions in JEE Advanced this year. So I guess what she is really telling us is that there is scope to start analyzing the JEE responses with these different inputs about the existence of negative marking questions, the number of negative marking questions, and the kind of analysis that Kate has presented us for the pre-Olympiad exams. Maybe those are something very much to look forward to such studies. And also another point she makes, which is the last point, relates to the last point that was made in the photograph showed by Nandini, and also something that Shubha Tole also endorses, and which we all of us endorse, that the PhD rates, the fraction in PhDs, particularly MSc students, and even at the PhD level, at the universities certainly is 40% nowadays. And that's what I meant by saying that if you look at the All India Higher Education Survey, you will find 40%, 45% as the fraction of women. But if you go to IISCs, ICERs, and TIFRs, then the fractions are not 40%. They go down to 20, 25%. So we still have to understand that. And as it's very clear, MCQs are a big part of the entrance to these institutes of eminence, but that may not be the only reason for the difference. And there are many facets, but this is indeed one point that I wanted to just read out. And thanks, Professor Kaur, for making all these very clear statements and giving us this input. Now, she also added one more thing, which I would have, because I had said that the fraction of girls in IITs is 10%, but because there has been what is called a supernumerary seats, extra seats that IITs allow, now this has gone to 20%, which is true. But I asked my friend Nilima Gupte and some friends from IIT Chennai, Sunetra Sarkar, and I asked them whether the supernumerary seats had made any difference in the number of girls which succeed in clearing the exam, a JEE exam. And I wanted to just share one slide of the data that I got from them, just to show you that, this is more the question of whether there are any psychological reasons for girls not succeeding, and whether the having a supernumerary quota, having the safety net of that, whether that would encourage more girls to do better. And what this data at least seems to indicate, that there is no such evidence of such impacts. So let me try to share my screen if I can manage it. But somehow there is something wrong here. 1 second. If I cannot share it in the next minute, I will give it up. Because I have already given you the conclusion. Yeah, here it is. So this is the, if people can see my screen, this is the, unfortunately I have very little data, but this is courtesy Nilima Gupte as well as Professor Sunetra Sarkar. And what they show is from 2013 to 2022, this is the absolute number of girls that cleared, qualified in the JEE. And 2018 is the year when the supernumerary quota was actually introduced. But if you go from this numbers, you really don't see any clear-cut pattern across 2018. In fact, it was increasing from 2013 to 2017, but at fluctuating. And it is, the numbers are, absolute numbers are a little bit bigger continuously from 2018 to 2022. But till we analyze what are the fractions among the total girls that appeared, how many total male students qualified, we won't be able to draw any conclusions. But the point is to only make that such analysis will have to be done. And as she has said clearly, that GAE is also trying to change its pattern and changing negative marking and so on. So this would be a very fruitful area to make further discussions. Now there is a question from Geeta Venkatraman, which I thought was a good question, and I wanted to pose it to all of you. Is there any difference related to gender between the MCQs which have one correct answer versus MCQs that have more than one correct answer, or answers which are very close to each other? So I know that both Debashis and we had discussed this a little bit in privately. So Debashis and Nisim both had comments on that. So I would like to ask you, either of you and others also who have knowledge, whether you want to take up this question and discuss it. Hello?
Well, I don't know if the data exists, right? I think Geeta is mentioning not questions whose answers are close to each other, but
Same
in questions there are also possibilities
multiply
of
correct
having
questions.
multiple correct answers,
Correct.
which actually the CSIR net exam adopts that in the mathematics, not in other subjects as far as I know. JEE also has that. I don't know of any studies, so I will not be able to comment. Maybe Kate have studied something and may want to make a comment about this.
Sure, yeah, although I don't have solid data on it. One of my PhD students had a bit of a play with that. She turned some multiple choice questions into multiple true false. So instead of having just one correct answer, there was a series of answers, and then it was label each as true or false instead. So you were effectively able to choose more than one answer. No consistent pattern. So with some of the questions that she converted, the gap went up, some went down, but she didn't see a pattern. And the data set, frankly, wasn't really good enough to draw conclusions from. So I think a larger study of that would need to be done with larger number of students and larger number of questions.
But then here I would like to ask a question actually to you, Debashis, because you, if I remember right, there were these discussions about having two answers which were rather close to each other, and there were were there some studies about it, or whether it was your personal opinion, I don't recollect. And I heard from Nisim that his computer has frozen.
Nisim who made that comment, not me.
Oh, but Nisim's computer is frozen.
Strategy to ask such questions.
But Nisim's computer is frozen, so he can't connect. So will they have to then?
I think that was actually, Rohini, that is not really the right scope of this discussion where we are discussing gender. There's more broadly
of MCQs. Yeah. So, yeah. So,
and I don't think there is enough statistics to further discuss these issues. I mean, it's more general comment that I made that one really needs to be trained in framing MCQ questions, since that is unavoidable because of the numbers, and whatever this kind of studies and further discussions on these to try to mitigate the gender ratio should be taken up. But other than that, I don't have any specific thing to say.
Okay. Actually, maybe let me ask, since Praveen's study was mentioned, Praveen, are you still around? And would you like to make a comment? Looks like he has left. So we have lost Praveen. Sorry about that. There is a question which is from Suchetana, but which fits more in the broader set of MCQ rather than gender. So I will read out the question and leave you to ponder over it. And I would like to then perhaps move the discussion questions over to the audience in the who are physically present there. Suchetana actually asked 2 questions: that should we design MCQ tests so they are unbiased, or should we design admission processes that are less biased? Now, I'm not 100% sure what this completely means, but I am reading out the questions. And it's more or less, again, going back to if there is a bias, how do we remove the bias? That is the general sense of the question. So if any of you would like to take up this question and comment on it.
Rohini?
Yeah.
Just after this, there is one question which is there, which has been marked by Debashish that he would like to answer it live.
Oh, I didn't
You can
see
take
that.
this after that. Yeah.
Okay. Thanks.
I could make 2 brief comments about what your question, Rohini.
Okay.
And just very briefly, 2 things. One is that I think in designing these questions, if we can involve more women faculty, that would be a very good idea. Although the situation in biology shows that it's not really foolproof, it doesn't seem to really eliminate the bias completely, but it will certainly help, I think. And from today's discussion, my takeaway lesson seems to be that negative marking has a negative effect on women in particular. So maybe one should discuss whether it is worth following that or giving up on negative marking, because I don't know whether it really adds to, it does any value addition to the selection process. And I want to also briefly remark on the effect of the coaching classes. Nandini had some very interesting observation about brain activity and all, which I do not know about, did not know about, but whether how much of that is inherently biological and how much of that is because of environmental training is something that it would be good to look at in future. So for example, I think the coaching institutes where predominantly boys go and urban population goes, that's where they teach them to take this kind of risks. So I don't know whether girl students who have been going to the coaching institutes, for them, the risk-taking ability increases or not. That kind of study has been done or not. But the effect of the coaching institutes is certainly quite significant in my opinion.
Can I quickly respond, Rohini?
Yes, please.
So, whilst looking for this data, there were 2 things that I found. The inherent difference in risk-taking is biologically well established over a number of studies. There was one study published by Hirschfield where they looked at students girls who took the SAT at the end of the year, and they took the same SAT 1 year later. And they found by continuous practice, there was an improvement. So there has been some research on that by consciously exposing them to risk-taking strategies, there is some improvement. Whether it makes up is what's not clear yet.
Can I chime in on this point?
Yeah, please do.
Rohini, just one sec. There was also a message from Praveen. Since you are called for Praveen, he has a lecture at 6 o'clock, so he had to leave.
Oh, okay.
Yeah.
Because I would have actually, for the coaching classes, I was wanting
to. Yeah, I know, but I think it's because we probably should have caught him on him earlier. Yeah, because he just sent a message saying that, and yeah.
Thank you.
And yeah, Kate also had raised hand earlier.
So now I'm going to ask Shubha and Kate to go one after another. And in between, Nissim's computer has unfrozen. So if you people can let him in. I know that he has a attitude about how to help and improve.
But he should be able to join in. There is no letting in. He should be able to join in.
Well, he just sent me a message saying that can I be let in? So, okay.
Anyway, we'll see, but I don't think there is.
Just see that. But anyhow, so let me recognize Shubha and Kate in that order.
Hello. So I'm a biologist at TIFR and also Dean of Graduate Studies. So that's how I have all the data that about the TIFR test. I've been, first I really learned from the various data that all the speakers presented. So thank you. It's a rewarding session to have been in. What I wanted to raise is something we all know. Negative marking and risk-taking strategies and how women versus men approach any exam really is the result of many, many years of social programming and conditioning. So we're trying to, we have women the way they are after all the years of programming and conditioning. And now we're trying to somehow find ways of assessing their inherent scientific or mathematical abilities in a way that somehow doesn't get biased by all of this programming. So this is almost an insurmountable challenge. And I think we have to have a two-pronged approach. While we are trying to shape our tests and worry about negative marking and so on, I think on as small a scale as is reasonable, I think we have to actually go back and start at the roots, start talking to 10-year-old girls. I sort of remember pretty much at the age of 10, I realized that things are different for women. And I spent, the entire next decade trying to wonder why. And I think I was the only one amongst my little group that wondered why. So although it's not scalable, I think if we don't do this, we're forever going to be trying to devise, sort of fix-it adaptations without addressing the root of the problem. And I submit here that it may not be as hard as we think. Sometimes it takes just one conversation. It takes just one mentorship session or one interaction to sort of awaken a spark that's already there and to say it's okay to feel you're misfit in your society. It's okay to wonder why it should be different. It takes just one. So what I'm actually saying is that we should, anytime we go and give scientific talks anywhere, we should actually have sessions like this. It's something I've been doing for the past decade. People don't remember the science I talk about, but they remember these kinds of sessions that I do. So yeah, that's just what I wanted to cover.
Okay, thanks very much. I would now like to go to Kate because she had typed a response about close questions and negative marking, etc. together. So I would like to invite you to do that.
So I actually wanted to pick up on the negative marking and risk-taking and strategies. Looking at the exams from India, where you have negative marking, the girls were answering fewer questions than the boys on both sections, which means that they're not changing their strategy, particularly from where you have a negative marking to where you don't. If you think about it, if you've got negative marking, if you take a random guess, then the expectation value of your mark is going to be a negative value. You're going to end up overall with a negative mark on the exam if you just chose everything randomly. And when I showed that graph, there were girls getting negative marks for the exams, which must have been absolutely devastating when they got those marks back. I mean, imagine you're a girl, you're sitting there in class and you've just got a negative mark back. So you're going to have this issue with damaging girls' self-efficacy by getting these dreadful marks, by telling them they're not just a zero, they're a negative, which is an awful, awful thing to tell a young person. But in terms of risk-taking is not a good idea when you have negative marking. It is a bad idea. That is what lands you with a negative mark. An effective strategy, depending on the balance of the negative marking and on the NCEP ones, if you can narrow it down to 2 options out of 4, then your expectation value becomes 0 and it's worth doing. And there is research that looks at different test-taking strategies for males and females, and males are more likely to use an elimination strategy. Now, whether that's because they've been taught more strategy, and this is something where the coaching comes in. If you tell girls, if you can narrow it down to 2 answers, take a guess. If you can't, don't. Either that or get rid of negative marking. Take it back to a bit more of a level playing field where the extra training is not advantaging the boys so much.
Okay. Thanks very much for making this point, because at this here, I also want to, in fact, read out a comment from S. Sen, and which kind of had asked this question, and I think this got addressed. He had said that he or she, I don't know who S. Sen is. So IIT JEE was not always MCQ. The change happened in late 90s. Even after the second phase was not MCQ for a while. Some introspection may be needed about the differential success rate in the early period. The coaching classes also used to be primarily through correspondence, so that would not disadvantage. That is his statement. So I think his or her, that is the statement of the person who typed this. But from what I can see, the responses that are coming in, these have been addressed, the questions, what is the opinion of the panel? The next statement, which I think is correct and very useful that we need to remember, is that we need to stay beyond the STEM subjects also to see MCQ affects performance in other subjects. And indeed, that is happening. And I'm happy that Nandini has already discussed it. So therefore, I think, sir or madam, whosoever you are, I hope Nandini's comments and other discussion has answered your question. So I think at least at this point, one has addressed most of the questions that were typed in question and answer, unless I missed something, Vandana.
No, that's okay. There is one more coming in from Pallavi already. But before that, I had raised a hand because I had to raise it physically. No, sorry, I had to raise it physically. As a host, I cannot do that. So I want to make two short comments. One is about this encouragement and mentoring. As actually, if you see, most of the reports of the lacking girls highlight that. And I just want to add something. Maybe it sounds a bit like advertisement, but the TIFR started Vigyan Vidushi summer school program for MSc first year students. This is the 4th year which we have. And we kind of have taken the feedback this year very recently from them. So about 150 students, we had sent the feedback and 100 of them responded. So one of the questions which was asked was, what is the role, the interaction and the mentoring in the school which they had? Was it helpful in making a career choice and helping them to decide in pursue science? We got almost 75% saying that was a very, very important aspect in that. So it is true that plays the role, but I think again, coming back to the answering the questions, I also have the feeling that these close answers and the quick decision making a decision even in a small time, that may be that is a significant factor, I think, in answering the MCQ as over and above the thing. Yeah. I think Ram has raised hand. While you are reading Pallavi's question, maybe Ram can say.
No, so you can, Ram, maybe you can make your intervention. And since you cannot find Pallavi's question, you read it after.
Okay, I'll read it. I have it.
No, I wanted to thank all the panelists for their sort of insightful remarks. I feel just a couple of things. Given the size of the cohort that takes examinations, any exam in India, some of these recommendations have to be very carefully thought about. In particular, removing negative marks you're not going to just remove it for women, right? You're going to remove it for everybody. And an exam like the CSIR net, where Devashish was giving you data about that, something like 80% of everybody who does the examination actually gets negative marks. So, there is a sociology to doing examinations in India, which we have to really think about, because a lot of people just come and do exams because they've got, in a sense, nothing better to do. So these big exams with large numbers of people attending, it may seem very nice to say that if you remove negative marking, that doesn't, women are less discouraged from answering questions. But you cannot do it differentially for genders. I actually would like to endorse what Kate and her groups are doing in Australia, which is to look at the question themselves. There is very little analysis that we do to the process of examination in India. We don't think, I mean, it's not just a question of does Sheila run 100 meters versus does John run 100 meters. That's, those are the more trivial ways of equalizing it. But, the analysis that she presented over here, there may be a culturally slightly different take that we have to adopt in our country, but I think that this is worth thinking about, that there has to be an analysis of the kinds of skills that are being examined and tested. I mean, while I can see that risk-taking, etc., all that goes in favor of men doing the examination, removing negative marks, or I mean, there's got to be a somewhat more nuanced approach to how we do this. The most nuanced approach may be do away with examinations altogether, and accept people on. No, I mean, I don't even mean that in a very facetious manner. Where possible, like TIFR and other such things. I mean, sometimes, the moment you announce that you have an exam, it's a race. And then there are some people who are going to run that race a little better. Anyway, so much for that.
No, thanks, Ram. But I think, as you yourself have said, in the Indian context, really things like GATE and JEE, I think this needs a different, not this 1 hour of panel discussion, but it needs actually a very considered thinking, because the numbers
Absolutely.
are huge and numbers are going to stay with us. Yeah. And we cannot change that. And therefore, we have to think of some solution. But that's so, I mean, I support some of the points you make, but I still feel that given the fact that we have to live with MCQs, we have to try and see how best to...
How to do a better job.
How to do a better job. And I think that is something on which we all will agree that that's a recommendation. And there are points which have been made by people. I think I like to thank Nandini and Kate particularly, because they have brought really very new information to the table and to our our knowledge. Now, we are almost at the end of this discussion, but I see Vandana raising her hand. So, yeah. Vandana.
So I think a couple of other people also made this point about social culture. So I think that is covered. But there are 2 comments by Riddhi, and one of them, Debashish had said he wanted to answer live. So I think we can take that. So the questions I'll just read out, though it's visible to everybody. It says one section in mathematics CSIR exams has questions with multiple answers, but no negative marking. And there's another comment is in JNU entrance test at master's levels, girls get extra deprivation points. So maybe we can give it over to Debashish.
I chose to answer that inadvertently. It does not, I don't know how to use this thing. So that is simply the point. So I don't know whether that part has negative marking or not. One has to check with CSIR. About the next point, I forgot to mention that about this deprivation point, which JNU practices, which used to practice for both entrance to the PhD as well as MSc program, but for the last few years, they discontinued it in PhD entrance and adopts it only for the MSc, Masters, not MSc, MA, MSc, all of them. The concept is some sort of affirmative action, but a graded affirmative action. All the districts of the country are divided into 4 different quartiles depending on studies of their development indices. And if you happen to come from one of these districts, you get some additional points depending on how deprived that district is socially and economically and from the point of view of other parameters. These points are given to all students who come from those districts. In addition, girl students from those districts get some additional points, and this is a form of affirmative action that JNU practices. Actually, Rupa was also involved and was instrumental in this process, so maybe I'll let her also comment on this.
Yes, I think this was JNU's own study to have this quartiles mapped, and in metros you didn't get anything. There was a review of the admission policy. I happen to share that. and where we looked at this in great detail. And I'm the one who brought in actually the gender angle to the retribution points. Devashish just said it all, but only thing I wanted to point out is that it's not where you come from, the last school attended.
Yeah, where you come from,
Yeah,
where you study.
it's nothing to do with your residence or whatever, and you can't avail this more than once. If you have already studied in Delhi, and though your residence may be in a backward quartile, that did not matter. If you're studying in Delhi and you're coming to JNU, you got nothing extra. So I think it was streamlined very, very well, and it showed, like Devashish mentioned at the beginning, that the representation that you see in JNU was quite remarkable because of this. So not just in terms of gender, but other diversities parameters as well. So I think that was a very, very good system to look at what's the last institution attended. And if you come from a backward district, to give you advantages, and a woman can actually get 10 extra marks. For men, it was only 5. So that was the thing. And it was supposed to be experimental for 5 years, study and figure it out and not go on forever. It's supposed to be a time-bound measure. I don't know what is happening now. But yes, we are all very proud of that.
Okay, thank you very much, Rupa, for that comment. And I would like, I think we are now really, we have some very interesting comments.
Nandini has hand raised.
But no, let me just, I know Nandini has raised her hand and I have privately told her that I'll be recognizing her in a minute. That was the point, that I would like to recognize her. And with, maybe I will make 1 or 2 very quick comments from the question and answers that people have typed. And after Nandini's comment, Nissim, I want, when you were gone, sort of, your computer had given up. We were discussing about how to help women strategize to clear the exams. And you had some small comments in our discussion. So I would like after that, if you possible, for you to comment on the strategies that you had followed in your, in your institute. So first, Nandini, yes, please go ahead.
I'll make it very short. And responding to Ram and the fact that Rohini also mentioned that we can't do away with MCQs, one very small fix I wanted to suggest, which I haven't found any data on, was in order to get girls to start taking risks, what if we made it compulsory that if you attempt all questions, you get 5 marks extra. Everybody gets it. Okay. And thereby you force girls to take risks. Okay. I just want to put that out there for consideration. I looked up I just thought of it and I looked up some research, but I haven't found anything to back it up. But it's just out there in case it can be considered. Nissim, the last word is yours.
Now, Nandini, actually, it's very good because Nissim had tried something similar. So actually, I cannot tell you how in consonance the two of you are. So Nissim.
Well, we are very old friends. Maybe that helps.
Yes. So I think that is one of the things that we've not tried it, but I think that is something that is well worth trying. Encouraging, essentially pushing people towards answering more questions. And the issue actually is a pointed one, right? That we've had a lot of input about the fact that many factors result in less risk-taking. There are social factors, there's training, networking, all of these result in less risk-taking. There's also a general issue that, at least in my experience, MCQs are not a good metric for researchability, which is, I think, an additional issue. But if you simply want to address the risk-taking or the risk-taking part of it, there's one obvious thing. One is that, a strategy that is taught to people is that when you're taking MCQs, especially the, MCQs at +3 and -1, +3 for a right answer, and -1 with 3 for 3 wrong answers, excluding one answer basically gives you a benefit. Excluding 2 gives you a large benefit. Excluding 3 gives you, of course, full marks +3, if you like. And this is the guessing is normally not done based on simply guessing 1 out of 4. It's guessing based on excluding one answer and then guessing 1 out of 3 or guessing 1 out of 2. That's where you gain. That's where you essentially game the system. And that's what you're trained to do in coaching classes. So I would say there's two things that maybe could be tried, and maybe so I would say that first of all, there's one issue, which is, should one retain negative marking at all in MCQs? And I think that's something which one really should be talking about seriously. But if one does, and that's a big if for me, then I think a number of things need to be done. One is that one should convey this information as explicitly as possible, that the strategy that you follow, that you benefit by following a strategy, and this is the strategy that you should follow, based on advice from people who are setting the exam, or advice from people who have looked at MCQ exams. Essentially, you should make that strategy open. So openness, I think, levels playing fields. Of course, taking that on board is not easy. And you need to do that over and over again. And we saw this, actually, I can give you, some input about the VSRP, because I've run the VSRP for the last 12 years in NCRA. In the first 3 years, I do statistics every year. In the first 3 years, we actually saw that the female fraction being selected was lower than the male fraction, at about a little more than 2 sigma, once you put Poisson errors in. And now, of course, I'm doing the selection, so implicit bias is a huge issue. And so I consulted with people and asked about, am I doing something wrong? And maybe if we continue this pattern, somebody else should do it, because maybe there are biases. And Bikram Fukan at St. Stephen's College pointed out something which blew me away. He pointed out that one of the things that we are using for the evaluation is a statement of purpose. And something that I had noticed was that women students were writing very short statements of purpose, or not writing anything at all. And he simply said that, why don't you just say explicitly that this is an important part of the evaluation? And I did from the next year. Suddenly, the number of people writing 0 statements of purpose or short statements of purpose went away. It became balanced across gender. And suddenly, the gender ratio changed. So it's sometimes even as, and the reason, of course, that Bikram pointed out to me, which I should have realized, but it says a lot about how one already is privileged, is that I would imagine that anybody would know this, but that's not right. I know this from my background. And if you don't have that background and that networking and that coaching, you don't realize this. But if you're told this, then very often you just do it. And you do a good job of it. You're actually competent. So I would say that in the negative MCQ thing, the important thing is to hammer home the thing that you really need to follow a strategy. And this is a strategy to follow. Because the strategy is not what we are not evaluating the ability to game systems. We are evaluating the ability to answer questions and to know how to get answers, if you like, or to get the right answer. So therefore, why are we trying to let people benefit from knowing a strategy which they learned from somebody? So I would say one needs to hammer that home, and one needs to put that in bold font right at the top of the question paper. This is what one should do. In addition to that, I think with Nandini's point that one should give a benefit to people who follow a strategy, for example, answering all the questions, is a very good one. That's the best way of hammering home such things, that you actually see explicitly.
But that is why I said that you two were in some sense, in consonance, because the idea is, if we have to live with MCQs, if for some reason negative marking cannot be done away with for other educational reasons, then one has to think how one can, and it is not just restricted to gender, actually. I mean, today we are talking gender, but any kind of exclusion based on, and that is already talked in terms of this deprivation points that people talked about. Whether or not one should add deprivation points, that's a different discussion altogether for a different time. But your response, one of the persons in the chat box typed it, that social conditioning, social backgrounds can also affect your risk taking, that can affect the way you think about strategize, and therefore bringing out the correct strategy is perhaps one of the very important ways of going on. And that perhaps doesn't need you to go to Kota to attend coaching classes. So I think it's up to our educational experts to understand and see how to move this forward. Plus, I think the other conclusion which is coming out in the Indian context, clearly we need more studies. Because all the studies, the nice studies that Kate and Nandini have provided us with, except one by Kate, is that we really need to look at India not just at the numbers, but for example, differentially, which questions do the girls fail on? What kind of questions do they fail on? I mean, this is going to require a fair amount of extensive study, but we do have MCQ states going on for a long time, and each of the organizations themselves might even provide us such analysis. That would be one of the recommendations that I can see, that a need of such information is something that is perhaps very relevant. That is one conclusion that I would like to kind of draw from this as to what do we want to have.
Kate has a
Okay.
point.
So is there any
Kate
more
has a
point?
hand. Kate has raised her hand. Maybe she can. make a
Kate,
comment.
please. So you will be given the last word, and I think.
Oh, I'm sorry. I didn't want to.
No, that would be very good, because then we would not be, even if we started 10 minutes late, we'll have taken only 10 minutes more than we planned. So.
Okay. So I guess what I wanted to say is the fundamental question you need to ask yourself, and every educator needs to ask themselves is when they're assessing, is what am I trying to assess? If you are trying to assess how good is a student at test taking strategies, then yeah, keep having negative marking. If you are trying to address the inequity of that sort of thing, then one way of doing that is, and there's this lovely cartoon, and I just found it online, but I can't see a way of pasting it in here. Maybe I can just super quickly screen share and show you this one. This one. So I think a lot of what's been discussed in the last few minutes is this middle cartoon here. We're going to boost girls up by telling them that they need to apply this strategy. And then we're going to boost them up a bit more by giving them deprivation points. Maybe instead, take away the fence. Stop filtering out the girls with the assessment practices that are excluding them in the first place. Because unless there's a really good reason for them, unless you actually want to make sure that your students are good at doing multiple choice exams, if that's what you value, that's fine. But if it's more about, are they good at physics? Are they good at thinking? Can they solve more complicated problems that aren't just a matter of eliminating multiple choice things? Then you need to be aiming more for something like this. You need to be taking away the barriers, not trying to give girls a leg up so that they can get over the barrier. So I guess that's...
Okay. Yeah. Certainly, it's a very valid point and a point of view. And
yep.
The question is how to achieve taking the fence away when one doesn't understand, one still tries to see how.
Yes, but I think that should be the aim, not compensating, not trying to make girls more like boys by teaching them to do things the way boys do, but by valuing the ways that the girls do things as well.
Point well taken. As I said, one just needs to explore all the avenues, at least that's my judgment. But actually, before one closes, one more thing is that, Munmun, can I request you to first ask if in the audience there is any comment, and after that request you to close the session by giving us.
Maybe we can take a few questions from the audience. So.
Yeah, if there are any, please.
Any comments, any queries? Okay.
Hi, I just have a small comment to make. What Kate basically said in the end, that, instead of, we are still trying to beat the game the way it is. And the games were formed when girls were not in the picture as such, not much as much. But now the game needs to be changed a bit at the back. So I don't have any strategies to say this, but just that, for example, somebody was suggesting that answer all the questions. I would just add another angle to it, that would it add more stress in the exam for the girls? That they are more stressful in the examination hall, because now there is an added stress. You have to answer all the questions, but at the back of it, you don't want to take that risk. So this is just my comment about all the discussion that was happening. So the way she just showed that picture in the end, that the game now is the way that everybody sees it. So probably the game is the the back of the game is what probably needs a change.
Anyone else?
This comment from you.
No. Would you like to comment anything? I don't see any raised hands here. Yeah, maybe people are quite tired. They can give some comments later on. Then shall I just summarize?
Yeah, can you just summarize and close?
Maybe I should face.
After which we will ask Professor Sushanta to give a
I should
vote.
face the live audience also. Okay, so actually today we had a session on a topic which actually many among us perhaps never gave a thought before. However, a significant amount of study are going on. We see the importance of the importance of exploring this very clearly coming out, and that's what was the motivation of today's session. We had panelists from a quite wide spectrum. We heard them. We listened to the discussions. So I would like to I don't want to take much time. I just want to very quickly summarize that we heard about the necessity from Professor Ghosh that the idea of the MCQs, and then the concept of standardizing or non-standardizing, and then how it may impact the gender scenario. We see that we need to review the strategy. We need to see the urban bias, the bias on trainings and skills, risk-taking, stereotyping, and many more. Then we heard about the data and the quick analysis from Professor Ghosal, Professor Nissim, and Professor Kate also from different scenario. Everything indicates that there is, of course, there are some pattern which needs to be tested more. We need to explore the risk taking, particularly by females, how to improve that. Different methods should be implemented there. Then even, it's also worth mentioning here again, what Professor Kate was showing, that just one word just, that significantly impacted the working scenario. So we need to parameterize different effects, factors which are affecting this. Indeed, this panel discussion is just a beginning, and now it's high time that we identify the parameters. We try to see how we can tackle them. We have also heard from Professor Nandini about these cognitive processes, a very entirely different perspective. We see that mathematical ability is gender unbiased. Then we see that the test taking strategy or the risk taking, that has a bias. So how to tackle that? So this is very important, and I would say the take home points from this panel. So without taking much time, I would like to just stop here. So I think the HOD will give the vote of thanks, and then we stop.
Okay, good evening, everyone. So I think now we have witnessed very exciting events and the discussion. It's time to acknowledge the people who have done this events happen for them. And now I think one line I will just say that RMCQ test gender. I think we all understand now the importance of this, and there are many more strategies are going to come, as I understood, and how it is going to be implemented, and new data will be coming, and we'll be looking forward for those events. And this webinar is a fruitful outcome of the Gender in Physics Working Group of the Indian Physics Association, together with the Shiv Nadar Institution of Eminence. And on behalf of this organizing committee, I thank all the eminent panel members, Professor Rupamanjari Ghosh, Professor Devashish Ghoshal, and Professor Kate Wilson, and Professor Nisim Kanikar, and Professor Nandini Chatterjee Singh, for sharing their knowledge and vast experience with the students and the academic community in this hybrid platform. And thanks to our VC, Professor Ananya Mukherjee, for all the support. And many thanks to Professor Rohini Godbole, Dr. Munmun Devi, and Professor Vandana Nanal, and Professor Subhabati Goswami for the wonderful initiative and who have made this day possible. And I also take great pride in thanking all the students, participants, research scholars who are here, postdocs, faculties for their presence and active participations. And I want to extend the vote of thanks to the organizing team. Here, yes, Dr. Priyanka here, and Priya Joris is there, I think, online. And then I want to say, that my special thanks to Dr. Sita Banerjee. I mean, she has communicated hundreds of emails between us, and all these things would not have possible. And so beautifully she has done this event. And I want to also thank this our department, my colleagues and physics department. And we are looking forward to organize this kind of events in association with this Indian Physics Association. So we'll be happy to organize this kind of satellite event in future. And I thanks to IT teams who are here for doing this event, and the admins and Hina Satya for sending several emails. And thank you everyone. And we are really happy to organize this from the Department of Physics. I'm proud to organize. Thank you.
Thanks, and I want to further add that we really appreciate the Shiv Nadar Institute coming up and organizing this in a very short time. And thank you very much for you and your entire team, and for Ananya for doing this on behalf of.
I would like to specially thank Kate, because it's almost late night for her. But I hope we can continue these discussions in another platform, and try to actually set up some project or one of the ideas. And this is something that I also want to leave you people in all the panelists with a thought, that one would like to make a summary of what we thought today together and present it to Equip during their session. So during the next few days, we would call upon help from you to try and prepare that summary document.
Okay, yes.
Thank you, everybody. And thanks again, Shiv Nadar people. You made it, thanks for all the arrangements. And all the best, everybody. So.
Okay, so I'll close the meeting now.
Yeah, please do.
Thank you.